Hey there, and welcome to the fourth section of this course, where I will go over various features, classes, interfaces, and operations of the Stream API, which is the backbone for Java functional programming. The topic for this video is understanding the Stream API and constructing streams, where we will learn about the fundamental concepts of the Stream API and the methods for stream construction. The Stream API in Java consists of a set of classes and interfaces. One such interface is a stream interface. All of the Stream API classes and interfaces can be found in Java util stream. The API allows you to create declarative pipelines for transformations of collections and arrays. A stream in Java is a sequence of objects from a source that is capable of self-iteration. This means that unlike collections, streams do not need an iterator to go through all of its containing elements. Internal iterations enables the operations on streams to be lazy when possible. Streams are called lazy because the intermediate operations are not evaluated until we add a terminal operation. Each of the intermediate operations creates a new stream but does not iterate through the elements until the terminal operation is called. Streams are functional in nature. They take the input and create an output without modifying the source. Because of their functional nature, streams allow for sequential and parallel execution, filtering based on given predicates, mapping of objects, and much more. Given the streams are a sequence of objects, you may be tempted to think that streams are a form of a collection, but that is simply not the case. Streams are definitely not collections. They are also unable to store elements. The simplest definition is that streams are a wrapper for collections or arrays, and not a collection or an array themselves. Streams work perfectly with lambda expressions. Streams are also consumable. The elements of the stream are visited once and cannot be revisited. To revisit them, you must create a new stream, just like how you have to create a new iterator to reiterate through a collection. Streams can also be infinite, unlike collections, which have to be finite. To execute an infinite stream in a finite time frame, you could use the limiting operation, which will be discussed in the next video. Because most stream operations return a stream themselves, it allows us to create a pipeline by chaining several operations on the stream. The pipelines consist of intermediate operations. These operations take input, process it, and return an output, which can then act as an input for another operation. Or we can end the pipeline by using a terminal operation. A more in-depth view on these operations will be presented in the next video. The Stream API provides a few classes for streams over objects for the primitive int, long, double. These are the inStream class, the longStream class, and the doubleStream class. The same rules for streams apply to these classes. Their purpose is to help us with manipulating primitives by easing the process of autoboxing and unboxing of primitive values. Streams can be constructed in numerous ways. You could construct a stream from a collection, using the stream or parallel stream method, as shown by the example. You can construct a stream from the static methods on the stream classes, like stream or inStream.range, and streams from random numbers from the class random, as shown by the sample code. With this, we conclude the topic for this video, where we learned about the Stream API, its most important characteristics, and a few ways for constructing streams.